Let's do a couple of these area problems together. If we were in school, we'd be doing more area problems, but now that we're home, we're kind of focusing on the calculator max min, finding the value, x equals, and finding the zeros. But we're going to do a couple of these because we should. Okay. Suppose a farmer has 1,000 yards of fencing to enclose a rectangular field. Find the largest area. Okay, so the wording on your paper and mine is slightly different. I just cut out some words. Oops. Okay. So here we have a rectangular field. Remember, your rectangle has the length and the width. It actually has two lengths and two widths because when we consider fencing, fencing goes all around the outside and fencing means perimeter. So your perimeter is equal to 1,000. So 1,000 then is equal to, I'm going to write it the other way. There's my eraser. So we're going to say that length, length, width, width. You know what I'm going to do? I'm going to turn this width into an x. Make that an x. I'm going to make this guy an x. So now x plus x is 2x. And length plus length is 2 times the length. It's like 2 times the length, 2 times the width. Add them is equal to your perimeter, which is 1,000. I'm going to simplify the entire equation by dividing by 2. If you divide every term by something, you can simplify it. X plus length is equal to 500. Now, this is written in terms of x. I need my length to be written in terms of x also. So we need that length to be solved for. So minus x, and length is equal to 500 minus x. So this is 500 minus x, and that is 500 minus x. Okay, so now that I have my length, here it is, and my width, there it is, in terms of x, now I can find the area. Remember, your area is length times width, and our length is 500 minus x, and your width is x, and that is equal to your area, and we're going to call the area y. We want to maximize, we know that, right? We want to find the maximum value of y. We want the maximum area. So let's plug this into our calculator now. And after I plug it in, I'm going to zoom 6, and now we got to find a good window. Okay, well that's going to be a neat trick. I see that it started graphing, and I am just going to go 100 first. I'm going to see what happens. 100 to the right and 100 up. Nothing. So I'm going to do 1,000. I'm going to go to my window. Let's try 1,000. And then we can always scale back if we need to. 1,000, and this is 1,000. So now I went over 1,000 on my graph and up 1,000 and graph. Oh, okay, so my graph goes up and comes down. Looks like I need to go up a lot higher, but I'm going to take a lot of this away. If this was 1,000, I'm going to come into 600 or 700. Yeah, 700. I'm going to come into 700, but my height has to be a lot higher. Okay, I didn't like maybe that's 10,000, right? So let's graph it. Ooh. I can see a little bit of the shape happening. I'm going to go back into my window, and I'm going to add another 0 at the end. Worst comes to worst, we always change it. I like it. I'm keeping it. Totally keeping it, and we want to find the maximum, and that's the maximum. So I'm going to second calc, find the max, which is 4. I'm going to arrow to the left, right, okay. 200. Okay, so I'm writing down my ordered pair. Remember, your ordered pair is x, y. Let's remember also that we said that the area is equal to y. So the maximum area that we'll find is 62,500 square. And I look back up top and it looks like it's yards. My x value in the ordered pair was 250. That means this guy is 250. This is 250. And 500 minus 250, well, that's 250 also. 250, and this is 250. And if you add up 4 250s, yeah, that's 1,000, and that's it. But we want the max area, so that's 62,500 yards squared. That is your max area. The second problem we're going to try together is this other one. So the owner of a ranch decides to enclose a rectangular region with 140 feet of fencing. Remember, fencing means perimeter. He plans to use, one side of his barn as part of the enclosed region, and now we're going to find the maximum area. Okay, so now that means there's his barn, and here's the enclosure. So we only need to put fencing on 3 sides. We need the fencing for the width here, and length here. Well, I know that my calculator doesn't take L's and W's, so I'm going to start turning this into X's. I'm going to make this width an X. I'm going to make this width an X. And that's my length. I'm going to remember that the whole thing is, there it is, 140. My perimeter is 140. So I'm going to come over here, and I'm going to remember that 2X plus this length here has to be equal to 140. I want to get this to say L equals, because I have to replace this with an expression that has X in it. So I'm going to minus 2X to the other side. And L is equal to 140 minus 2X. And then sometimes when I'm stuck where to go, I always start with a formula. Remember, we're maximizing area, and area is length times width. This is your length, so that's 140 minus 2x times x. Area is y. So let's plug that guy into our calculator and see what happens. So here it is in the calculator, and I'm going to zoom 6. And I got nothing. So just like before, I'm going to go to my window, and I'm going to start with hundreds. I'm going to know that my height might be 100, and it might be 100. Oh, there's the height. And it might be 100 out. So I'm going to graph. Oh, good. You know what? I like the 100. I'm going to leave that. But it has to go much higher. Much higher. So I'm going to go to my window. I need to go higher. That's this. I'm going to try 1,000. Ooh, that's pretty good. I'm going to go a little bit higher, maybe 3,000. And that's a really good window. Okay, so guessing and checking, hopefully you're getting good at that. Now we have these really dark lines here. I didn't really address that ever until right now. If those bother you, if they don't bother you, leave them. If you want to know why they're dark, it's because here in your window, your scale was never changed. Your scale is what are you counting by? And if you are going as high as 3,000 and you're counting by ones, well, that's 3,000 little lines, and that's why those lines are like that. Maybe instead of counting by ones, if you're going up to maybe you want to count by 500s. Or if you're going out as far as 100, maybe you count by 10s. And if we do this, then we see that we're counting by 10s, 10, 20, 30, 40, 50, 60, maybe that's 70 if we need it. 500, 1,000, 500, 2,000, 2,500, so on. Okay, so that's how that works. We need to find the maximum. Second Calc 4. The maximum happens here, so x is 35. Well, x, remember, is here, so that means that this side is 35. The other side is 35. 35 and 35 is 70. 140 minus 70, your length is 70. So we have all of those dimensions in case we ever need them, but the y is your area. And your max area is 2,450 What do we have here? Feet. Feet squared.